And welcome to this video. Today we gonna look at a bit of a smaller topic, and that has to do with the security of operating system, the secure operating system, and the corresponding software architecture around it. In the next session, following this one, we will look into the system hardware architecture, which is a bit of a bigger domain to cover, and that's why, just for the sake of clarity, I'm keeping these two sessions separate in order not to overlap or overload the information in one session. So this is gonna be a very small bit, but this is very important because most of the things that human experiences working in the computer is through the concept of kernel. Uh, that is where the capability of operating system really comes to its power. We do not directly now type into hardware to generate information or meaningful data. We interact with the hardware through operating system, and operating system at its core has a functionality of kernel which act as an interface between the hardware, operating system, and then that operating system is accessed by users to perform meaningful calculation, derive information, etc. So the kernel at its core of the operating system, it's a ring zero. That's why if you recall the ring structure that we have seen in the previous domain from 0, 1, 2, and 3, it stands at 0. It is the innermost layer. And as I said, it interfaces between operating system, the applications, and the hardware. So this is your gateway towards the hardware computing, where you do not want to directly interact with the hardware. There are different kind of kernels that exist. So we have a monolithic kernel, which is a static executable, and the kernel runs in a supervisory mode that we have seen in the previous session. What are the modes? And all the capabilities of the monolithic kernel needs to be precompiled. It does not have the capability on a runtime to make an execution. It only acts as a interface to pass the information and execute the precompiled steps. So it does not have the capability of compilation. Microkernels, on the other hand, are modular kernels, and by modular, what it means that the different functionalities of the kernel are handled by different components. And one of the important aspect of microkernels are that they can run in the user mode 3 instead of in the supervisory mode, and they can also adhere to or handle non precompiled instruction, which allow it to be much more usable, which allow it to be much more versatile than in comparison to the monolithic kernel. Now, one of the core functionalities of the kernel itself, it being the core of an operating system, is to act as a reference monitor. And this is a very important terminology. In the exams of the CISSP, they do test this concept of a reference monitor. They do mention that in a question, so you should know what a reference monitor is. It's a core function of a kernel, and what it does is that it helps to handle the communication between the subject and the objects, making sure that the right policies are executed given a particular subject needs to access a particular object. It also manages what you call as the audit file to see what has been done in order to, let's say, investigate if something goes wrong. So reference monitor as a policy controller is a very, very important concept in the kernel functionality, and this is something you must remember. You must have a very clear understanding of what a reference monitor is. Then we can look into a couple of examples of how this is implemented, how the kernel functionality is implemented at the operating system level. For example, if you look at the Linux or the Windows operating system, you know that the file permission on Linux is managed by read, write, and execute capability, which belongs either to the owner or the group or at the world level. Owner, which actually owns the particular file, group to which an owner may belong or a user may belong who is holding the accessibility to the file, or the world file is like public file, which is readable and writable to anyone. Windows has a bit of a different architecture there. It is called new technology file system, and where it does what it does actually, that it implements the read write execute concept in a bit of a more layered structure. So you have read write execute, but you have other parameters as well, which is like a full control, which is a combination of read write and execute, and changing permission. Dominantly, Windows operating system works on a discretionary access control, where access can be granted based on the discretion of the owner, even at the operating system level. The Windows processes determine where you should or someone should get access or not. For example, an user will not get access to the kernel because that's the core of the operating system, and if that is disturbed, the whole operating system will get disturbed. So that's why you will never get direct access to the kernel. Of course, there are administrative accounts like the root in Linux that has been created to have access to the kernel, and that's why it's a very potentially high profile account, which if get misused can literally crash the whole operating system. So that's why the usage of such accounts is either prohibited or done under extreme situations of having a high priority or a very emergent incident that requires this account to be used. Windows also have the wash admin account and some of the core AD, some of the Active Directory controller accounts, which or the cal accounts, for example, which are created in the administrative group, and they are also very powerful. So with that, I'll stop here. I hope that you be able to gauge the importance of kernel in the operating system. Next, as I said, we will look into the system hardware of architecture more at detail in the next session. So up until then, thank you very much for listening, and I hope to see you in the next session. Thank you.